1, 2, 3. Good morning, class.
Good morning.
I have a question. How are you doing today?
I'm doing very well. Thumbs up. I'm happy.
Very nice. Lee,
Yes.
what did you have for dinner last night?
For dinner last night, I had bacon and cheese sandwich.
That sounds delicious. Alassa, what did you have for breakfast this morning?
I had an omelette and some juice. Orange juice.
Oh, juice. I used to like juice in the morning, but now I can't drink it anymore. I think it's something with the acid. It just makes me all queasy. So, it gives you energy, yes?
Yes.
Because it makes you ready for the day, to learn, to come to school. Now, I have another question. Have you eaten cheese pizza before, Erica? Yeah?
Yeah.
You like it? Okay, good. Good. Amara, do you like yogurt?
Yeah.
Yeah? Yogurt's pretty good, right? Okay. So I have this pizza right here. Delicious pizza. You guys can help yourself to a slice of pizza while we have a little discussion, okay? So here's a slice of pizza. Would you like some pepperoni pizza? No? Okay. No takers, okay. No takers on the... Wow. Where would we be if we didn't have dairy? What would happen? If we couldn't have any more dairy? If you couldn't have yogurt, what would happen? Find your own time. Nice. And what would you do if you couldn't eat your cheese pizza?
Have to find pizza without cheese.
Oh, would that be devastating? I'd be sad. I'd be sad. I love cheese pizza. I don't know about you guys, but cheese on my pasta, on my quiche is delicious. I love it. I love cheese. It's very nice. So, how would this affect your health if you couldn't get dairy, let's say, like yogurt and milk, into your diet? What would happen to your health?
I think it has a lot of calcium, so that you're in deficit of calcium.
Yes. So if you have a deficit of calcium, what would happen outside? What would happen?
We should think of other ways to compensate the shortness of calcium.
Exactly, that's why we got to find another way to fix the problem. So that would affect our health. Our bones would maybe break, and we'd have to find an alternative. So today we are going to talk about food, obviously. If you had all one eating pizza during class, feel free to step up and get yourself a slice of pizza. Now, we're not going to talk about the food that we eat, though. We're going to be talking about the food that everything eats, all organisms. Whether you're a producer, a consumer, an herbivore, a cow, a piece of grass, we're going to talk about where do you get your energy. So, we're going to connect food chains and food webs. We're going to develop an interactive model. We're going to use a food web to predict the effect of population changes in an ecosystem. And then we will investigate what other changes could affect a food web. Okay? So to start off, I'm going to have you guys work in groups, as you are, to sort these into what eats what. Can you do that?
Yep. Yeah.
Okay. There you go. You guys go.
Should we start from like the top and bottom?
You can sort these however you want, just to sort the pictures how you think they go.
Okay. Where's your ready
There might be. I just gave you some items to see if you can make a food chain. There could be 2 food chains. There could be 2 food chains left. So, or you can make one, just depending on how you think. I'll give you another minute to see what we come up with.
I'm almost like me.
Yeah,
There we go.
it's too big.
This one, I don't know.
Let's see.
It's possible.
One,
It's good. It's
2, 3. I like what I see. Okay. You guys already naturally made a connection with one of the objectives. Okay. We were going to start with food chains. Just basically one animal eating another animal, eating something else, and just making one link in a chain. But you naturally made the connection between other animals eating other animals. So this is all very nice. So we have the clover, and then perhaps we could have the mice, or so if we bring the mice over here.
The mice eat the clover?
Yeah, the mice eat the clover,
Raccoons eat mice.
and raccoons eat mice. Yes, there you go, and that's it right there. That's what we were going for right there. Keep that on the board here.
Mice do?
So we have clover to mice, to raccoon. That was one connection that I was going for. The other one was acorn, squirrel, and then owl. Okay? That was like the essential. Yeah, an owl will eat squirrel and mice. Okay? But you all make the natural connection that an owl will eat a mouse, will eat mice. So that's what we're going for right there. Okay. What would happen though if all of a sudden a disease came in, all of a sudden the squirrels got a disease and they started dying off? What would happen to the population of the owls and the squirrels, do you think?
Well, first I'll find a different food to eat.
We could. So what would be the alternative food?
Mice.
Mice. Okay, so we'd have to go here and eat the mouse. The mice.
Would further deplete the mice population.
Yes, so this would go down. Correct. Thank you, Erica. And then what would happen to the population of the raccoons?
also go down because they don't have as many mice to feed them.
And then, Lee, what would happen to the population of the owls? Okay, that's one possible outcome. If all these two are going down, the owls may have enough food. Maybe it's a bigger predator and can eat more, right? So very good. And that's what we're going to go further into. We're going to be developing a Great Lakes food web. We know the Great Lakes. Maybe our fathers go there and do some trout fishing. And they go out every weekend in the season. They love to cast their lines and get the fish, get the walleye.
We camped there once in the spring.
Is that, winter camp? Is it springtime, summertime?
It was during fall.
During the fall. Very nice little campfire. So we, so we know it very well, and we like it. So we're going to look at the organisms inside the Great Lake. So each one of us is going to be individual organism. So yes, we could. Yes, you're going to pack those up. Okay, I'll take the baggage. Thank you very much. All right. There you go. Pick one, any one. There you go. Now you guys are all specific organisms. You may not know what it is. So that's why on the back I wrote down what it might be. It might help you out. Okay, as we try to make our food web. But let me ask you something. Who has heard of food webs? Everyone? Yes? Okay. What is an example of a food web? Amara, what do you think of web when you...
Chain, food chain.
Okay, so we're thinking food chain. What other words would have web involved?
Connection.
Collection? Okay, we got collections.
Spider's web.
Spider's web, exactly. Spider's web. So that's what we're essentially going to be creating, like a spider's web, an interconnection between all these organisms, okay? So now that we know what a food web might entail, let's stand up. We're going to make a circle. Pushing your chairs. Okay. Now, who has the producer? Who has the producer? Who is the... What producer are you? Microscopic plants. Okay. So, Amara, you're a microscopic plant. You do not eat anything. Where do you get your energy? Not quite. The plants all get, it's like a plant of the water. And the sun, yes, like the color of your shirt, the bright, beautiful yellow sun, right? It gives energy to the plants, and that just trickles on up the food chain, okay? So our food web is going to start with you, okay? So right now we have this ball of yarn. So it's going to start with, you're going to hold the string, okay? You're going to hold the ball of yarn, and go ahead and spread out a little bit more, okay? So now your job is to throw the yarn to the organism that eats you. So hold up your organism. Maybe I should make it a little bit bigger.
Can you just say
Eggs.
Mosquito
Small
long.
fish. Small fish.
Herring. Small fish.
blue heron?
Well, there we go.
Mosquito larvae.
So what might eat this mosquito larvae, Lee?
Let me see.
Look at that.
Blue heron.
Big fish.
Little fish, big fish. Little fish. Oh, hold on to.
Oh,
Yeah,
yes.
hold on to
Oh,
the
yeah.
is. So when you throw it,
Keep.
Thank you.
Keep.
all right.
Cool.
Oh wow, this is the start of the spider, if you will, as he goes across to limb, making spider webs.
Yeah, I had one.
Now, Mr. Big Fish, or Small Fish,
Small fish.
what eats you?
I think it's me, a bigger fish.
There you go. Hey, right there he is. Mr. Trout. Okay.
Right. Trouts.
Who's going to eat the trout in this circle?
I'd say the blue heron would.
Yeah.
Yeah, it's a blue heron. Beautiful blue heron. Okay. Now, is there anything in this circle that's going to eat the blue heron?
What do you have? Freshwater what?
Clams.
Oh,
Okay.
clams. Freshwater
Ah.
clams. Did we miss something?
I would. I don't know.
So
No,
what-
Freshwater
I think
clams.
a fish eats clams. Oh no.
What does the freshwater clams eat?
They say microscopic.
They might see other plants. So that's another food chain. That's another food chain. Oh, excuse me, I'm gonna have to get through here. Okay. Now you're gonna have to throw that to the snails? No, the clams. Okay. Then what's gonna eat the clams?
Small fish.
Small fish. Oh, nice catch. That's nice. And what's eat the small fish?
Bigger fish.
Bigger fish,
All human being.
Exactly. So.
And back to
I'll
blue
I'll
heron.
eat you again.
Okay, so now we've all got a piece of the connection. We're all part of the ecosystem, all being fed, right? This looks very cool. Now, if there was another, if we had more students here, right? We were missing a few of
Yeah.
our class today. So that's where we have Mr. Algae right here. Okay, he's another part of the food chain. So we'll put him in his chair. He's absent. Okay, and what's going to eat algae? We have aquatic snails and insects. Okay, they eat algae, but maybe not microscopic plants. They're making a different food chain. So there we go. So the reason we're doing this is we're going to get to a fish that also the trout likes to eat. Okay, so then we got these perch, beautiful yellow perch. So perch eats insects and snails. So now it's a part of the food chain. Food chain, food web. And we got the walleye, which some of our dads like to fish for too, right? So now we have this walleye. Thank you, Erica. Appreciate that. So here's this purple one. It's going to go through. Food web's going to go there. There, maybe to the insects, to the perch. Go the wrong way. Tight those caught. Oh, that's what's probably wrong. Here. Black one. Okay. Wow. This is going to be difficult. We're going to pass it over to Amin over there. So, hold on. We got a
Hold
lot.
on, I've got a lot of.
Close that real quick. Don't go.
Oh no. Okay. Grab the scissors from over there.
Scissors right by you, Chris? No?
Try this.
Got it.
Yeah.
Nice and done there.
Can you hold that? Pull. There you go. Okay.
Okay? You got good room. Okay. So now, whether you look at it from the bottom or top, we have this web, right? You can look at it from underneath if you can. Take a look at it underneath.
Yeah.
What do we have?
Web.
A web. All right, now put it down. What do we have? A web. It's still a web. We're all still connected together, right? Okay. Hey, Mr. Trout over there is getting a lot. He's getting a lot of food. Okay. He's getting a lot of food, and then the blue heron is also going to get a lot of food. But let's say if something like a disease comes into the Great Lakes and kills off the, what were you getting, Mark? Microscopic plant. Let's say if a bacteria comes in and or the algae comes in, takes over all the area and kills the microscopic plants. Drop your string. What's going to happen to the rest of the food chains, the food web? If the plants die, who eats you? Oh, that's going to die. Oh, they die. And then, yeah, you drop the blue and the white, and then you drop yours. Oh no. So now then all we're left with is the algae and the insects. It's just one food chain feeding our Great Lakes, which is that good? No, that's not good. We're gonna have very unhappy dads or moms that can't go fishing, can have the peace and quiet of having the children outside the house. So it's not good. Okay, that's why it's so important to have this healthy ecosystem. Okay, so go ahead and drop the string, and go back to your table. We'll clean up here in a minute. Okay, just go ahead and get back to your seats. Thank you. Right you don't have to roll it up just yet, you can just drop it. Right now, what we're going to do is, while the memory's fresh, like if this was a big class, this would take a while to clean up. And while you guys are thinking about the importance of the interconnection of all the organisms, I want us to do a little journal writing. Okay, so we're going to open up our journal. The lesson has ended. Okay, we've met some of our objectives of connecting food chains and food webs. We developed an interactive model, and we've used a food web to predict what would happen to the population changes. And the investigation will come tomorrow as I give you some article to read about the Great Lake, about an organism. Okay? So our journal writing, as you know, starts off with the date. It is February 8th, 2019. And the title is Food Chain and Food Webs.
What's the time?
Yes.
I know it's the volume.
Yes, you may go to the bathroom after you answer this question. What is an omnivore?
Let me think.
Mm.
Omnivore, I think it's an animal that eats both vegetation and meat.
Yes, you are correct. You may go to the bathroom. You're
Cool.
So on your journal, I would like you to write down what you represented, okay? So you'd have to start off with, today I represented, okay? And you draw the organism that you represented.
Thank you.
You're welcome. Then if you can't see, Amin is already drawing a sketch of what you're representing. Very nice. That's what I was going to ask you to do. It's just like you're being in the field. I want you to sketch, draw your organism if you can, okay? So that's the second thing I want you to do. Draw your organism.
Next step.
Now the last thing I want you to do is to write down what would happen if your organism got a disease, got hunted too much, and it died off, or the population went down. Write down what would happen to the population of the rest of the organisms in the food web, in the ecosystem. 1, 2, 3, stop. Writing, please. All eyes on me. Thank you very much. Thank you for writing that. I saw some beautiful pictures and you read some beautiful pieces. Now what I want you to do is to share, to swap books with your neighbor, okay? And read what they wrote. Write down a comment also, if you want to, on what they wrote. Okay? Two, three. Okay, stop writing. Put the books back. Now that you shared with each other, do you guys have any questions, or would you have about what you about today? Any questions?
I had a question thinking about blue heron.
Yes.
As part of the food chain, so it's a top carnivore. So if something were to, like a disease that we talked about, or maybe so it becomes extinct, right? What happens when there's an overabundance of the lower parts of the food web? Like how does that affect the ecosystem if there's too much of something by the top carnivore being gone?
So it'll start to overpopulate, and if all of a sudden there's no more blue herring, the trout will become overpopulated, and then yes, great for fishermen. So then the trout will start eating more. Who ate you? What did you
I
eat?
had the small fish.
Ate the small fish, and the trout's going to eat more of the small fish, and then it's just going to still trickle down until the bottom of the food chain starts to die off because there's not enough, and then it'll come back up.
So there would be an abundance of herring, but
Be of trout, and then the trout's going to eat more herring, and then the herring is going to eat more clams. Were you the clams, Lee?
No, I was in the ski.
Okay, so it's going to eat more clams. The clams are going to eat more microscopic plants, and then there'll be fewer microscopic plants. So it may take time, but eventually the microscopic plants will get smaller.
so it wouldn't mean that there's abundance of everything. It would just be there would be an abundance of the one below.
But then it will
Yeah.
balance out because then it's going to be less over time. That's what.
Oh, yeah, so over time everything is together.
And so if you wanted to prevent that, if you knew that happened, you could open up the hunting season, the fishing season earlier, and then go after the trout. Okay, the fishermen, you have to go after the trouts. And there's actually something that is, happened in the Great Lakes. We're going to read about, I'm going to write an article about. So they opened up the Erie Canal to go from the ocean into if you're familiar with it, into the Great Lakes. Well, there is the sea lamprey, there's an organism that can go between salt water and fresh water. So now it doesn't have anything to kill it in the fresh water. So now it's just becoming overpopulated. So it's going to start eating all that, because this is the top carnivore for the water. So there's nothing there to eat it, so it's going to start eating all the trout, all the walleye, are taking food from the walleye. And then the walleye population is going to go down, but the sea lamprey is going to get bigger.
Can you eat it?
Mm.
Can you eat a sea lamprey?
Oh, why don't you go home and answer that? Now, let's ask here. You have these yes and no in front of you. This is what I like to use it for some games. Check see if you recall any information. So, microscopic plants. Producer, is a microscopic plant a producer? Yes. Oh no. Okay. So now that we see that the microscopic plant is a producer. Okay. A blue herring, is it a top carnivore? Would the population go down if would the population of blue herring go down if the population of the trout went down? Yes. Okay. Very nice. Do you guys have any other questions about food chains or food webs?
No.
No? Okay. Very nice. I'll see you guys tomorrow.
Thank you, sir.
You're welcome.